All right, recording is rolling. This is Thursday, October 28th. The main thing we're going to do is a launcher lab outside, but right before that, there's one more row on this energy table. It involves two asteroids that start from rest and are gravitating towards each other from, well, pair points A to this pair points B as they're gravitating towards each other. Right, so what's in the system? This is a closed system of two asteroids. I'll say independent rights. Each asteroid. Right? So two masses, M and M. So they each have the same mass. Right? Energy at point A. Well, if they start from rest, there's no kinetic. I don't see any springs, so no spring potential. Hey, how about gravitational potential energy, right? Now, if I say gravitational potential energy, you usually reach for MGH, right? But that doesn't work so much here because MGH, if you look at that lowercase g gravity field, uh, if you have objects changing distance compared to each other significantly, isn't that g going to change? Right? Lowercase g, MGH really is an approximation for like at the surface of a planet, which is not the case here. So you have to use the universal form of potential energy. You guys remember what that is?
Negative GM.
Boom! Negative g m divided by r. Okay. Since they have the same m, I'll just do that, and then this would be r sub a. You could say negative gm squared divided by ra because, of course, same math. Right. Then they'll gravitate towards each other, so they get closer. Say point B. So I guess the potential energy would be decreasing as they're getting closer, but also where is some of that energy going? Into kinetic. Okay? So it would look like this: negative g m over r sub b, okay? Plus 1/2 mv squared plus another 1/2 mv squared, okay? Like for each one. Right? Now you can combine those terms because they're same mass, same speed, right? Uh, and then you can do some algebra. You can say this is equal to this. Right? Now I didn't give you guys any numbers, but uh, let's make up something. Right? What if this is like negative uh, 50 joules, negative 50 joules? Right? Then as they get closer together, doesn't the denominator decrease, which makes this overall fraction what, bigger or smaller? Bigger. And since it's negative, maybe it's like negative 70 joules. So just make something. So negative 50 joules to negative 70 joules. So where there's a difference of like 20 joules, right? So this might be like 10 joules and 10 joules. Right? You guys get that? Right. Now you could say this is equal to this and then solve for v. You guys could do that, right? All right. Enough of that. On to the lab.